Welcome, my friends and colleagues. This is Professor Ali Tarrad, accompany you in this episode to introduce some of the important applications of heat exchangers. And here we are talking about the shell and heat exchanger. How does it work? What is the structure of this type of heat exchangers and where can be uh, found. And thank you for subscribing for this channel, and let us see the content of this episode, and I hope that you will enjoy its content. Now, my friends, let us go to see what are the objectives of the present episode, which is related to the shell and the tube heat exchangers. First, we will pass through the description of a heat exchanger and its structure. Then we will go through the operation description and how these heat exchangers work, and then we uh, will introduce some of the operational problems in the industrial field for these heat exchangers, and finally we will reach at the closure of the present episode. One of the main components of this type of heat exchangers is the tube sheet and the tube bundle. In this photo, we may see that there is a tube sheet, and the tube sheet, in fact, is uh, a piece of metal perforated with holes, and these holes usually are corresponding to the number of tubes of the heat exchanger, and usually the tubes are connected to this tube sheet by soldering, and on both sides there could be tube sheets on the left hand side and the right hand side of the heat exchanger. The tubes inside the heat exchanger are corresponding to a shape just like the bundle as shown in this photo, and the tube sheet contains the number of holes which are corresponding to the number of tubes in that heat exchanger, and usually these holes are prepared in the form of a number of tube passes of the heat exchanger. So we have tube side fluid that enters through the tubes, and we have on the shell side another fluid. Of course, the objective of these streams are either to heat or cool a process fluid. So one of the fluids usually is called um, service fluid, and the other one is called the process fluid. For example, if we have an operation in industrial field in a hydraulic system, for example, to cool down oil, then the oil will be the process fluid. And it could be cooled by passing water. And the cooling water is called the service fluid. And the cold water could be obtained from the cooling tower. So in this photo, we may see a bundle of tubes, and they are supported by baffles, a baffle. And these baffles are structural material made of a metal that can hold these tubes together inside the heat exchanger. And it could be clear in this photo. For example, this is a sort or a part of heat exchanger from the shell type, shell and tube type. And on the shell side, there was oil which passed through this heat exchanger. And the tubes are shown, and these tubes are supported by the presence of baffles. U-tube arrangement. The tubes of the heat exchanger could be manufactured in the form of a U-tube. For example, here we have the tube sheet perforated with a number of holes which are corresponding to the tubes. And on the right hand side, we have the other end of these tubes in the form of U. And the tubes are fitted in the tube sheet as shown in this part, the middle part, and the fluid passes through these tubes to the end and return in a U shape to the same end of the uh, tube sheet. That means in the U-tube arrangement, you may have the fluid to in and out at the same direction of the heat exchanger. In general, this is the shape of the tube, and they are manufactured prior to the operation of manufacturing the heat exchanger. The heat exchanger structure. In this photo, we may see a set of shell and tube heat exchangers which are installed in an industrial site like petrochemical factory or refineries like oil refineries or food industry. So there are too many applications for these heat exchangers. Here we have a simple structure of heat exchanger, which is composed of one tube pass, and the fluid in the tube side is labeled with blue direction. It enters from the right hand side and leaves on the left hand side. And we have on the shell side the red arrow direction, and we may see that the fluid on the shell side having these curved arrows passes between the baffles and then leaves at the right hand side of the heat exchanger. And in this way, we have a counterflow uh, flow between these two streams. And here we can summarize the structure of heat exchanger, that it is composed of tube sheets, tube bundle, baffles on the shell side, And then we have nozzles for in and out for both of fluid streams. And of course, we should not forget the tie rods, which keep these baffles in situ as well. So these are the most or major parts of the heat exchanger. And now let us talk about the baffles in the shell and the tube heat exchangers. In this photo is obvious that a bundle of tube is supported by these baffles as shown, and there are many advantages from the use of these baffles and heat exchangers, of course. And the most common type of baffles is shown in this the blue photo that we have um, plate with a specified thickness, and it is perforated with these holes, which allows passing of tubes. And the advantages of the existence of these baffles in heat exchangers, they control the heat transfer coefficient on the shell side and control the pressure drop as well on the shell side. So these two parameters, important parameters in the design of heat exchangers, um, can be controlled by the controlling the distance between these baffles. Minimizing the distance, it means that we are increasing the velocity on the shell side, and in that way we are increasing Reynolds number and improving the heat transfer coefficient. On the contrary, that will increase the pressure losses in heat exchanger. So usually these two parameters should arrive at a compromise because the pressure drop is counted for the uh, power required to run the pumps. And this heat exchanger is only part of a big layout and the network of these piping systems, valves, and other equipment. So we should minimize the pressure losses inside the heat exchanger. The other advantage that the presence of these baffles will create a true process flow on the shell side with fluid that passes through the tubes. And finally, they provide a mechanical support to the tubes. Uh, so we can keep them in a straight way uh, and at the same time strengthen the structure of heat exchanger. And usually these baffles have a cut, and it is stated by a TEMA standard to range between 15 to 45% of the inner shell diameter. And then I will explain what is TEMA standard in the next slide. The baffle types which are used in manufacturing of shell and tube heat exchangers. The first type is called the single segmental, which is the most common type of baffles. And we can see in this animated diagram that the fluid on the shell side enters the shell from the left-hand side and passes crossing the distance of the heat exchanger through these baffles as shown. and that will make a perpendicular flow between the shell and the tube side. And these baffles can be made of a plate with a specified thickness. Of course, these thicknesses of baffles of the tube sheet and tubes usually is controlled by TEMA standard. And these baffles have a circular shape with cut, and the common cut is around 25% of the inner diameter of the shell. The second type is the double segmental type. In this type, we have three pieces, one which is a central, and the others are uh, fixed on the inner uh, diameter of the shell. If we look at the left-hand side shape, that the two pieces are fixed up and down, and between them the flow. And then we have the main central part is fixed. Then the flow will be divided into directions, and then we have a sequence of these uh, baffles as shown in this figure. Of course, this type is used to minimize the shell side velocity, which is reflected in minimizing the pressure drop. So this is a solution or another option to minimize the pressure drop as well. We have the third type, which is the disc and dove knot. As shown, is again we have two parts. A small part which is fixed at the middle, and then we have the other one which is fixed on the inner side of diameter of the shell, which allows the passage of these tubes. Of course, these are the popular shapes and types of baffles which are used in manufacturing heat exchangers. Let us have a look at the flow pattern on the shell side of the shell and tube heat exchanger. Here we have a simple diagram for the shell with the baffles fixed. And let us consider uh, this shell is occupied by a tube bundle composed of 12 tubes with fluid passing on the external side. And let us take one of these tubes uh, as shown in the shell, just to show how the fluid flow patterns on both sides could be. We have inlet and then passes between these baffles, and at the end exit on the other side of the heat exchanger. And we have two fluids, the blue one on the shell side and the red is passing in the tubes. And we have a complete or a true counter flow and cross flow for this type of arrangement. And we should mention here TEMA standard, which is Tabular Exchanger Manufacturer Association, uh, which is responsible for creating a standard for manufacturing these types of heat exchangers, and an abbreviation called TEMA. And especially the thicknesses of these parts of heat exchanger, uh, which is composed of tube sheets, plates, the shell thickness, the tube, including the effect of corrosion, erosion allowances, and so on. Everything is uh, put in a standard of TEMA. And the tubes which are used in the uh, manufacturing of these heat exchangers are specified by TEMA to be between 9.5 millimeter and 50.8 millimeter. Among other problems of heat exchangers and uh, those arises from the use of heat exchangers in different applications. We have dilapidated piping system as shown in this photo uh, with different diameters, valves, joints, and it is connected with other equipment. So some of these problems usually arise during the operation of the site, industrial site. And here we have a sort of disrupted pipeline network in an oil refinery site, which cannot be used in normal operation of this system. Therefore, this system should be stopped and then rebuilding a new one. And these problems could arise from either a severe process uh, uh, condition which are exposed to these piping system, or maybe it could be due a mal design for these heat exchangers. For example, we may have such systems when we have chosen material which is not suitable for the process fluid or service fluid that is passing through these pipes. For example, here we have a heat exchanger which is completely blocked, and this is either to reasons related to the design or the material selection, or even if there is no maintenance. If you leave the heat exchanger to operate for a long time without maintenance, it will end with these conditions of tube bundles and the heat exchanger itself. As you can see at the right hand side, there is a corroded heat exchanger which is completely cannot be used in any operation. So usually these are some of the operational problems that can arise during installation, and we have experienced many problems as well in the heat exchangers in power plants, especially the condensers, because we are using river to provide water for cooling, and it is already contaminated or contains many other solid materials which block the tube, and at the end uh, you have to get out these heat exchangers from the service. Now we arrived at the final part of this episode, that is the closure. And in this episode, we introduced two important topics. The first one is about heat exchangers, and we focused, of course, on the shell and the tube heat exchanger and where it can be used and its structure and the types of fluid flow in the shell and the tube side, and we have explained that. And the second point was about the problems that arise during the operation of these heat exchangers in industry. If you found that the content of this video are useful to you and others, please subscribe to the channel and share its content with the others. And I will see you next time in other videos. And bye bye.